Okay? So if you look at this question, and I say, hey, rationalize the denominator. What that means is you've got to change an irrational number that was in the denominator to a rational number. How do I do it, Danny?
Okay, so you just need to multiply it by square root of 5.
Okay. So guys, nothing is divisible here. This is a binomial on the top. To rationalize this denominator, we multiply both top and bottom by the square root of 5. Why? It's just not a standard in math for us to leave radicals on the bottom. And we want a universal way for everyone to write the answer. Guys, this would be monomial times binomial representation. So this is like multiplying a binomial times a monomial. What's root 2 times root 5? Root 10. What's 3 times root 5?
15.
Oh, no. This is going to be 3 root 5. Constants multiply coefficients. Radicands multiply radicands. Guys, what would be left on the bottom? What's root 5 times root 5? 5. Okay. When you look at this, the coefficient here is 1. The coefficient here is 3. And the denominator is 5. Do you see a common factor in 1, 3, and 5? No. So this is as simple as we can get. This is your rationalized expression. Yeah? Okay. What if I had this? And I said rationalize. Okay, Danny answered the last question. Can someone else?
Can you rationalize this one?
How do we rationalize this one?
Times.
If you just do root 3, you're wrong.
Is it 2 plus root 3?
It's not 2 plus root 3. It's 2 minus. Guys, why do we use the conjugate? That's called the conjugate. So the reason why we have to use the conjugate is because the middle term will cancel and the radicals will disappear. So whenever you have a binomial denominator that you're asked to rationalize, we use the conjugate to rationalize it. So this is, again, monomial times binomial. So this becomes 8 minus 4 root 3. Is everyone good with that? Now this becomes binomial times binomial distribution. I want to see the middle term canceling. Okay, so I want to see the 4 coming down to 2. So 2 times 2 is 4. 2 times negative root 3 is negative 2 root 3. 2 times positive root 3 is positive 2 root 3. And then a positive times a negative is a negative. Guys, what's root 3 times root 3?
9.
Root 9. But what's the square root of 9? 3. Instead of writing the square root of 9, you guys should just know that that's 3 at this point, right? And then you show me this elimination. Should I write it over 1? Do we write fractions over 1? Anything divided by 1 is just itself. So final answer. And this is actually a really nice, concise way of representing that rationalized fraction. Okay? Let's try one more. And then I'm going to give you guys the advanced example, and then I'm going to give you guys the practice quiz, because tomorrow is the quiz, and tomorrow is the homework check. And I'm checking all the homework from 5.1. I'm checking all the homework from 5.2. And if you show me answers alone, it's 0 credit, right? So you guys have to show the math. What if I have 2 root, let's go 2 root 3 plus 5 root 2 all over the square root of 6 minus 1. Okay? This is a binomial, and this line says, hey, we can't put these together. These are unlike radicals. They can't be put together. And then this is a binomial. How do I rationalize the denominator? Danny, go for it.
You can divide it by 2. I mean, like 2, there's 5 square root 2. You can put it like 1. Oh, no. You need to use conjugate.
We have to use the conjugate. Okay, yes. Guys, what is my conjugate? And guys, you have to show me the... I always have people who are like, I'm super lazy, and they do this. They just make a really big This is not how you show the work. You have to show me that it was a fraction that was equivalent to 1. Okay? So this is lazy, not full marks. This is, when you multiply by the conjugate, you have to show me that whatever you're doing to the bottom of the fraction, you're also doing to the top of the fraction. This represents multiplying by 1. And you have to show me that you multiplied your fraction by 1. Right? Okay. Miel, where would you begin here when you do the binomial distribution on top? What do you got?
I wasn't working on it. Hold on. I would get 2 root 18.
Okay.
And plus 2 root 3.
Yeah.
Plus 5 root 12 plus 5.
Are we okay with this, guys? Are you guys okay with those 4 terms? Okay, and then when I work on the bottom, there's a lot of work to be done on the top. I hope you guys recognize that, holy smokers, we've got perfect squares here and we've got perfect squares here that we're going to have to dive into, right? What's the bottom going to be? Kara, tell me what's my bottom.
6 plus 1 root 6 minus 1 root 6
Okay, so guys, do you see that the square root of 18 is the same as 9 times 3? Which would become 2 times 3 root 3. Are we okay with 6 root 3 there? Did I lose anyone?
Yeah.
Okay, just teasing then. Okay, so I'm just going to work on this. I'm just going to work on the 2. So somewhere on a scrap piece of paper, just because this gets really complicated, I know that there's perfect squares in 18, and that perfect square would be 9. So this becomes 2 times 3 root 2. Which gives me 6 root 2. There was already a coefficient. I square rooted the 9. It gave me a 3. 3 times 2. Do you see the 6 root 2 now? Okay? But this is grade 10. That just becomes a part of your grade 11 question, right?
Oh, it's 2 and 18.
Yeah, there you go. Okay,
Yeah.
So now I've got 6 root 2 plus 2 root 3. Now let's look at the 5 root 12. Okay, so grade 10, 5 root 12. Guys, what's the perfect square? It's a factor of 12. Do you guys see the 4? So when you look at this, you're like, oh, that's the square root of 4 times the square root of 3. What's the square root of 4? What's 5 times 2? 10 root 3. Are you guys good with this now? Most people kind of just do a real quick mental math here, and then they go straight to the 10. So they'd be like square root 4 is 2, 2 times 5 gives you 10. So your radical skills from grade 10 have to be like really quick and fluid, because it becomes just one small piece in a bigger question. Now on the bottom, I get 6 minus 1, which is, am I done? Please don't say yes.
No.
Hey, Brayden, what am I going to do now? We got like terms, guys. We got like terms all over the place. I've got like a 6 root 2 plus a 5 root 2 gives me how many root 2s? 11 root 2s. And then I've got a 2 root 3 plus a 10 root 3 gives me 12 root 3s, all over 5. Now, we can't break into the radicals. We can't put these together. Is there a common factor in the 11, the 12, and the 5? We're done. That's our rationalized expression. So the first part of 5.2 was multiplying binomial radicals. That just becomes one small piece when you're rationalizing. Okay? So the last example. So if you were absent, you watched the podcast, you made sure you were clear. This is an advanced example. And it says, express the volume of a right rectangular prism in simplest radical form. How do you find the volume of a right rectangular prism? How do you find the volume of a prism? Length times width times height, right? When you guys were in junior high, whenever you was always like, area is equal to the area of the base shape, and then you multiplied by the height. Well, if my area of my base shape is a rectangle, except I can't spell rectangle, then it would be length times width times height, right? So your that's not supposed to be area. That's supposed to be volume. Sorry, volume. So volume is equal to length times width times height. Okay, what should you recognize here? Do you guys see that these are conjugates? It would make sense for you to want to multiply those first, because you know that when you multiply conjugates, the radicals disappear. So, when I'm going to come up with my volume, it's a binomial of 6 root 2 plus 2 root 3 times the binomial of 6 root 2 minus 2 root 3. And your brain has to recognize these are conjugates. This is going to come out to be a nice neat integer. And you should know how to do that binomial multiplication. Okay? So, let's do binomial times binomial first before we incorporate the root 10. Guys, what's 6 root 2 times 6 root 2? 36. What's root 2 times root 2? 2. Okay? No. 6 root 2 times negative 2 root 2? Negative 12 root 6. Positive 12 root 6. And then we've got positive 2 and negative 2 is negative 4. What's root 3 times root 3? Okay, this is just my binomial distribution of my conjugates. This is 72 minus 12. So when I put these like terms together, like you can just type it into your calculator, 36 times 2 minus 4 times 3. We end up with 60. And we're multiplying that by root 10. The final answer is actually just 60 root 10. There's your volume expression. So the volume is 60 root 10. This question is so easy if you recognize multiplying the conjugates. Right? We know that multiplying the conjugates is going to take you like from potentially 4 terms down to 1. Right? Okay. This was homework I assigned yesterday. You should have all your homework done for 5.1 and 5.2. If you want the opportunity to get the rewrite on Monday, you're going to make sure that you've got all your homework done tomorrow for the check. Okay? So, we're going to come back